So 6.2, we're going to talk about law of cosines. So 6.1 was law of sines. This is law of cosines. Our formulas are different, and we use them when we're given different things. So we would use the standard form formula when we are given a triangle that's side, angle, side. So we wouldn't have a pair to use law of sines, so we would have to use law of cosines. And then we use the alternative form when we are given side, side, side. So in example 1, we have to find the 3 angles of the triangle shown. It gives us 3 sides, so are we going to use the standard form or alternative form? Alternative form. So it gives us the formula here. We always want to start by finding the largest angle first. So which would be our largest angle, A, B, or C? B. How did we know that B was going to be the largest? Because it has the longest side. So B is the longest side, so it's paired with the largest angle. All right, so we're going to use our formula, plug in everything that we have. We're looking for angle B. So cosine of B is equal to 8 squared plus 14 squared minus 19 squared over 2 times 8 times C, which is 14. So just be careful in putting this into the calculator. You can do it all in one, but if you're not careful or don't know how to put it all together, don't like using parentheses, then just do it all separately and subtract it individually. All right, so when we put this in the calculator, you should get negative 0.45089. Is that our angle B? No. How do I find the angle B? I have to do the inverse cosine, so that cosine -1 button of this that I just got. So I would keep it in my calculator and do second cosine of that answer. And you should get B is equal to 116.8 degrees. So I found angle B. What should we do next? I can do law of sines now. Now that I have a pair, I know that angle B is 116.8. I have side B, so I can do law of sines now. So you could do law of cosines again, but it just may be easier to use law of sines now that you have a pair, because now you're just setting up a proportion. So this would be 19 over sine of 116.8 is equal to, let's find C next. So 14 over angle C. So sine of C. So from here, I would cross multiply. I get 19 times sine of C is equal to 14 times the sine of 116.8. Can divide both sides by 19, and then we're going to put this into our calculator. So all of that gets put into the calculator. So we should get sine of C is equal to 0.6576. What would I do next? Do the inverse. So I would say the inverse sine of this number here. So I would get angle C is equal to 41.1 degrees. Now, how could we find angle A? Add them together and subtract from 180. Perfect. So it'd be 180 minus 116.8 minus 41.1. What do we get? 22.1 degrees. Perfect. So those would be our 3 angles. So here we are given two sides and an angle. Do I have any pairs that I could use law of sines with? No, so I have to use law of cosine. So if I'm given a side, angle, and side, would I use standard form or alternative form? Standard form. So which side are we looking for first? A, because it gave us angle A, so I'm going to use the first one. So I have A squared is equal to B squared, which would be 9 squared, plus 12 squared minus 2 times B times C times cosine of A. So 2 times 9 times 12 times the cosine of 25. So we're going to put all of this into the calculator. So we should get 29.237. Is that my answer? Do you think this is my final answer for A? What do I have to do? Square root both sides. So we have to square root both sides. So we get A is equal to 5.4. Now we take the square root of both sides. Usually we would put plus or minus. Why are we not putting plus or minus here? Because we're talking about a side length, so it can't be negative. So 5.4 meters. We still have to find angle C and angle B. So what would we do? We can use law of sines now that we have a pair, because I have angle A and side A. So I would say 5.4 over the sine of 25 is equal to, I'm going to find C first. So 12 over sine of C. We cross multiply and then divide. So we would get 5.4 times sine of C is equal to 12 times sine of 25. Divide both sides by 5.4. And then we put this in the calculator. Bless you. So we should get 0.939. What would I have to do next? The inverse sine, because that is not what sine is equal to. That's not what C is equal to. That's what the sine of C is. So do the inverse sine of this number. And that'll give us the angle. So we should get 69.9 degrees. So angle C is 69.9 degrees. All right, now that I have two angles, how can I find the third? Subtract from 180. So 180 minus 69.9 minus 25. 85.1 degrees. So we found our two missing angles and the missing side. So these would be our three answers. What's wrong with our triangle here? Looking at the sides and looking at the angles. They're not set up right. Our smallest angle doesn't match this. Well, our largest angle doesn't match the largest side. These two are off. These two are off. Because angle C should be bigger than angle B, right? Because side C is bigger than side C. So, Stefano, did you find angle B first here? So, perfect. So that will happen sometimes, but you just have to check your work at the end where the sides don't match up. So what we would do, instead of finding angle C first, we would have to find angle B first. Yes. So you always have to make sure that the largest angle matches the largest side.
But like on web assignments,
It would mark it wrong.
there's no triangle, but you just have to figure out.
So we want to find B next. So I would say 9 over sine of B. Now we would cross multiply and we do it all again. So sine of B is equal to 9 times sine of 25 over 5.4. We put this into the calculator. We get sine of B is equal to 0.704. What would we have to do next? Inverse sine. So we get sine is 44.77. Oh yeah, we could say 44.8. So now how can we find C? We would do 180 minus 44.8 minus 25. What do we get? 105.2? 110.2. $44. Sorry. So these are our answers. So you just always have to check your work at the end. But when you find the smaller side, the smaller angle first, it will eliminate that possibility of happening. But always double check. So we had to find the side first, but then the second thing we want to find is the smaller angle. Well, how did we know which angle is going to be smaller, angle B or angle C? B, because side C is smaller. So it's smaller than side C. So it's going to be smaller than angle C. So the second thing we want to find is the smaller angle. All right, example 3. The pitcher's mound on a softball field is 43 feet from home plate. The distance between the base is 60 feet as shown in figure 6.9. The pitcher's mound is not halfway between home plate and second base. How far is the pitcher's mound from first base? So we are looking for H here. So what would I need to do to find H? So I have H squared is equal to, we can say F squared plus P squared. So 43 squared plus 60 squared minus 2 times 43 times 60 times the cosine of 45. So we're going to put this into our calculator. All right, so we should get H squared is equal to 1,832.329. And then what would we have to do next? Square root. So 42.4. 42.4 what? Feet. So we have a formula for the area in our law of sines, but that won't work if we're given 3 sides of the triangle. So we have this Heron's formula, which will work if we're given 3 sides. So if we're given 3 sides, you want to find the area by using Heron's formula. So Heron's formula is the square root of s times s minus a times s minus b times s minus c. And we get s from this. So s is equal to a plus b plus c divided by 2. Again, these will be given to you. So all you need to know is how to plug things in. Okay? So here we want to find the area. First thing we need to do is find s, because we can't use our Heron's formula without knowing what s is. So we add all the sides together and divide by 2. So we have 53 plus 43 plus 72 divided by 2. So we get S is equal to 84. Now S, we have to use in our Heron's formula to find the area. So it's the square root of S, so that would be 84, times S minus all of our angles. So 84 minus 43, 84 minus 53, times 84 minus 72. We put all this into the calculator. So before we take the square root, you should get 1,281,168. And then we take the square root of that. So the area is 1,131.9 what? Meters squared. Perfect. Because our area is always the unit squared. So meters squared. So there's 3 different formulas for finding the area of a triangle. Our standard one that we know and love is 1/2 base times height. But if we're not given the base and we're not given the height, then we can use one of these, which we talked about when doing our law of sines. So these were our law of sines ones. But then if we're also just given 3 sides, we would have to use our Heron's formula, which would be this. So these are just 3 different ways of finding the area of a triangle. Just depends on what you're given.